It's time for project challenge number 3. Well done for getting through the first 2 project challenges. So we're going on with the Schmitt trigger gate. Last time we had a little oscillator, in fact a bunch of oscillators, which was looking quite interesting. So just going to reiterate this. So here we are. There's a Schmitt trigger oscillator, this time with a 56k resistor. It's half the value of the 100k we used last time, and it flashes twice as fast. But again, to reiterate what we're doing with AND type of gates, in this case a NAND gate, we wanted to say that we have the possibility of remote controlling. So you could have something like a light sensor or infrared remote control or something like that. So just pretend it's over here. That's the other input here. And if we go low, it stops the oscillator working. It's just stuck at high. And if you go high, the oscillator works again. A little bit of a pause to get started, and then it just carries on oscillating. That initial pause is where the capacitor is just first charging up, and then it's just up, down, charge, discharge, charge, discharge. Right, that's that one. Now, let's get on to the thing we're talking about at the beginning of the experiment here, the automatic tap. Now, the automatic tap is something which is very irritating in many cases because you're washing your hands and the water's on, off, on, off, on, off, on, off, on, off, on, off, and it's like a bang, 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 and you hear the pipes banging. It's really stupid. So we are going to make something that can solve that problem. It's called a retriggerable monostable. Yes, it just looks like a NAND gate, but what we do with the input is quite clever. Now, it's using this kind of memory that we're talking about is for, and it's using the 100k, but instead of being connected to the output, it's now connecting to the plus 9 volts. What is it doing? We've also got a switch here. Well, one way to find out is to rig it up. So what we're going to do is take out the 56k in this case, so the oscillator stops working. It's okay, I'll leave the power on, it's all right. And so then we're going to put 100k now from the capacitor just to some blank column over here. Then we need to have the variable resistor to go all the way up to 9 volts. That's fine. So we just go from the resistor that we just put in. Then we go to our variable resistor. It doesn't matter which end, just goes to an end, and then we just tap into the wiper of the variable resistor, and that goes up to plus 9 volts. And the display's gone out. Let's see what happens. Now, last thing we need to do is to add in the switch. Now the switch is already connected to ground on one side. I just need to connect the other wire to the switch. We can do that. So that's going to be the capacitor input. Just got one more wire here, and then we just couple to our switch. Now we've been using a 4K7 resistor up here. We don't need that anymore. Take it out, and we just put the wire instead. Right, what happens? We press the switch, let go, and after a while it turns off. Press the switch, let go, press the switch, let go. Press quickly. Still, it takes a time to turn off. Now, what does the variable resistor do? Well, let's just go over a little bit more. Press the switch. Takes a while. Takes quite a long time, and then it turns off. So every time you press the switch, even quickly, takes quite a long time to turn off. Now, that could solve our tap problem, because it means that when you're washing your hands and it detects your hands in there, it turns the water on. Even just quickly put your hands there, it'll turn the water on, and the water will stay on, allowing you to wash your hands with moving like this, and then eventually it turns off. Maybe 2 seconds is just nice to set, and with this control you can do it. There you are.